Assalamu alaikum. In our last session, we did some data manipulation in R using deployer package and created this file, and we saved this file with data.csv name. Today, we will continue with this file and try to make graphs with it, data visualizations using this file. So first of all, we need to read data from this file. So if you remember from our last session, to read data from CSV file, you have to type command which is read.csv, and in here you have to you can see some parameters of this file. Here you have to give file path, which is we will choose from file chooser, file.choose, then header is equals to true, and let's store it on our variable called that's data. Let's run this command and choose our file. So you can see our file has been loaded in the environment. You can again view our file data by with the view command. Uh, View and then variable name, which is that's data. So this is our file, and we will try to make graphs from this using this file. So to create graphs, first of all, we need to download a library called ggplot. To download it, you have to type install.packages and type ggplot2. ggplot2. Run this command, and a library will be downloaded. You can check the library in this packages tab. ggplot. You can see I have already downloaded this library. Now we need to use this library. We can use this library by clicking on it. It will automatically add the code, or we can write code of, we can type library and then name of the library, which is ggplot2. So that's how we can use this library. So to plot graphs from this library, you just have to type command ggplot. This is a function for creating graphs, for creating plots or graphs. You can see in the first parameter you have to provide data source. So our data source is that's data variable, that's data. And second parameters, in the second parameter you have to provide the mapping, which is in asterisks, and here you have to provide x-axis as well as that's y-axis. So here I want to plot number of deaths with respect to years. So let's populate x is equals to column name, which is year underscore id, and y is equals to second column name, which will be average underscore deaths, avg underscore deaths. Let's run this command and see what happens. You can see when we run this command, there appears a graph in which x-axis is year id, which starts from 1990 to 2015, and y-axis contains population, sorry, average deaths, which is in the form of powers. Later on we will change these values here too. So it just creates a blank plot. uh, to plot some data on this graph, we have to use some geometries. Just type the plus, put plus symbol, to combine these commands, and then you have to use geometries, geom underscore, and there are a lot of geometries you will find. For example, I'm going to use geometry point geometry here, and let's run this. Now you can see uh, four different lines which are uh, which are showing data of the graph. We are currently not able to understand what these lines are showing, but these are showing something. So let's go into detail of it and find out what these lines are showing. So what I'm gonna do is I'm going to assign. In this file you can see there are actually different different points on the same years. For example, if you see the picture, you can see on 1990 there are six different points. There are six different points because 1990 appears six times, one time for male, one time for female, and every cause name is different. So that's why they are appearing different times. So let's assign different color to the cause name. Uh, Let me cause underscore name. Let me copy this command and type it below here, and to make it more readable, here we can assign different colors to it so the graph may look a little bit more clear to us. Let's say color is equals to and column name, which is average underscore deaths. Let's run this command. uh, Sorry, we don't want to assign color to average deaths. We want to assign color to cause name, so that would be more useful for us. Color is equal to cause underscore name. Let's run this. Now you can see it has assigned different colors to different causes, like injuries are colored as green. So these deaths are by injuries, and here are non-communicable deaths which are in blue, and similarly some are in red. So uh, our graph is little bit more clear to us now. Let's continue modifying the graph, and let's say we want to distinguish we want to distinguish male and females to assign different colors or different shapes to different shapes will be better. Let's assign different shapes to them. Color is equals to cause name, same as above, and let's say shape is equals to, let's assign different shape to this column. Shape is equals to sex, and let's run this now. Now you can see male deaths are shown by this triangle, and female deaths are shown by a circle. And now you can see these are male deaths, and these are deaths by non-communicable diseases. And now our graph is much more uh, descriptive. Similarly, we can merge, or we can combine different types of geometries, such as uh, this is a point geometry. Let's combine line geometry with it. So to combine any geometry, just type again plus sign and then name of the second geometry, which is, let's say, gum is equals to underscore line. And let's run this. Now you can see we have points as well as lines. So two geometries are combined in one, and we can also say line type to it. So it shows a line here as well, because it is showing here but not showing here. uh, let's say shape and comma line type is equals to 6, and run this. And where is the mistake? Let me figure out. I have made some mistake here. And just here is a mistake. We have just missed one round brackets here. These are AES round brackets, and we have just missed the ggplot round brackets. Let's close this and run this command again. And then again we have some error, which is unexpected symbol in gum underscore line ggplot. Okay. Oh, sorry, brackets were not added properly. Again run this command, and let's see our graph. No, it has distinguished lines too. You can see male line is a little bit dotted, and female line is straight line without any solid line. So that's how we can play with the graphs. Uh, let's play some furthermore. Uh, Currently, uh, these are two ugly, like x-axis says year underscore id, and left y-axis says avg underscore deaths. Let's give it a proper name. To give it a proper name, you just have to write one more. You just have to attach one more command, which is labs, and here you have to provide all the labels. For example, let's say title of the graph is deaths per year. Similarly, on x-axis we have years, and on the y-axis we have number of deaths. And let's run this. Now you can see our graph has title, uh, a proper message on x-axis, as well as a proper label on y-axis. And what if we want to distinguish graphs? We want a separate graph for males, and we want a separate graph for females. We can do it just by simple command, which is facer trap. So that's how it looks more readable now. We just have to write one command, which is facet underscore wrap, and here we have to type the column name on which we want to separate the graphs. We want to separate it with sex, so let's type 6, and then join the other commands. Let's run this. Now you can see we have two different graphs, a separate graph for female and a different graph for male. Note these two graphs are different. Similarly, we have different types of graphs. Like we can have om underscore smooth, gm underscore smooth. Let's see how it looks like. We run this. Uh, Basically gem underscore line, in gem underscore line you will see edges because it is direct to the point, but gem underscore point is gm underscore smooth is a smooth line. You are not able to see clearly here because of the size. Let me open some zoom. Okay, just skip for it. No, we will see it in some other examples. Similarly, we have different types of graphs. Let's copy this and let's plot a different graph. Remove these two geometries, these three geometries, and all these extra parameters. We just want x-axis, y-axis, and for example, if we want to plot a bar graph, we need to provide color we want to fill. Without color, it will be really ugly, like gm underscore bar, and let's see how it looks without color. In bar graph, you have to provide stat, which is identity. It is used in bar graph. So that's how bar graph looks like, which is very ugly right now. Let's give it color to again the death cause. We need to fill it with cause name, so we can see it's. Now you can see this is a bar graph where green color represents injuries, blue color represents communicable diseases, and pink color represents communicable disease. Similarly, we can use different types of graphs. We have a lot of type of graph. Here is a cheat sheet. Some graphs work on two variables, like we have used gm underscore point, gm underscore smooth, and similarly we can gm underscore bar, stat is equal to identity. Similarly, we can use different types of graphs as shown is in this file, and some graphs work on one variable, for example, in which we need to just provide x-axis. We don't need to provide y-axis on them. For example, these graphs works on just single variable, and these graphs work on two variables. So we can draw any kind of graph as shown in this picture. Now let's load some different data and try building graphs on it, explore some more details of ggplot2 library, and let's create a variable, name it any variable, my new data, and then read.csv. This time I'm going to give link of a CSV from the internet. I will place this link in the description of the video too. So I have just placed link of a CSV file, and let's read this file, and you will see this file will appear on the environment section. It is currently downloading it from the internet. You can see this here. Okay, graphics viewport cannot pop the top level of the grid in graphics output mixed. Okay, ignore this. Ignore this warning and let's view this file. What is in this file? We need to first of all familiar with it. Summary of my new data. What is it? So this file contains average life expected and GDP per capita of different countries. Let's view the data. GDP per capita, population, continent of the country, and similar things. With respect to years, let's view the data file. View my new data. And you can see, for example, Afghanistan in year 1957 has population of this, is located in this continent, has average life expectancy of 30.33 and per capita GDP capita is 820. So again, let's try to create graphs with this data. Similarly, same process, ggplot, first data source, my new data, second asterisk, x is equals to, let's say, year, and y is equals to population. These are the variable names. It's year and population, and let's try again point graph. So you can see here point graph similar to we did before, and this time let's give it a different color to continent. Color is equals to continent, and now it has assigned different colors to different continents. For example, Africa is orange, and we can assign colors by our own choice too in it. In R we have a package called R color scale underscore color underscore pure. Question mark in front of any command is used for help. It will open up manual of this command. So here it has opened the help page or manual of that command, which describes the pure scales, provides sequential, diverging, and quantitative color schemes from color viewer. From these websites, you can see different colors of it. Open in browser. So here are different colors. You can use different color schemes to use your graph. So that's how we can here are some built-in colors. We can assign some built-in colors to it. For example, let's assign built-in color to this command. You can assign it using command scale underscore color. underscore beer, and here you have to type different colors names. Let's see, pretty is equals to, you can find colors names from these websites. uh, Here are different types of colors. These are their color names. So you can assign any of them, and I'm going to assign the first set 1. Let's run this, and you will see now colors will be changed according to the set 1. Similarly, we can assign manual colors. You just need to assign colors of the categories. For example, here we have 1, 2, 3, 4, 5 different colors. So you can assign colors manually using command, which is scale underscore color underscore menu underscore manual, and here you have to type values uh, in the form of a vector. So we need to provide 5 different values because we have 5 distinguished variables. So let's say red, blue. You can also provide hexadecimal codes here, yellow, green, and let's say black. So that's how you can uh, change colors of it and modify it according to your own design. But no, you can, this yellow color seems uh, is really difficult to see. Let's change this color to somehow, let's say, pink. See, currently you can see the graph is really scattered on the bottom. To view it more clearly, we can take log of it, log of y-axis, and then display it, so it will be a little bit more spread. So let's say plus, uh, we need to take log of y-axis, so scale underscore y underscore log of 10, and let's see. So now our graph is more spread instead of scattered at the bottom. And similarly, we can create different graphs using this cheat sheet. And now let's try to modify some data which is on x-axis and y-axis. Let's change the breakpoints. This one, let's see, let's say, because y-axis looks really ugly right now, 1e plus 07. Let's make it more readable. So scale underscore y underscore continuous, and here we will provide our breakpoints. Breaks is equals to, we will provide a vector of breakpoints. Let's say our breakpoints is 0, then one test pause, uh, let's say, and similarly let's create different breakpoints. Let's then 13 and 15, and we can give name to it, such as labels of them. Again, list of vectors, it says 0, then this will be 70 million, 70 m, then 100 million, 130 million, 115 million. Let's run this. Currently our breakpoints are too much scattered, so that's how we can provide our custom breakpoints as well as our custom labels. So that's how we can play with our graphs. We can create different graphs, we can customize it according to our needs, and we can display it in different colors. Then we have different themes as well as uh, we can use different themes. Let's say we have different themes. We can use themes are used for coloring the graph, for example, which is theme underscore black and white. It will change a little bit appearance of the graph. You can see it has added some borders here. Similarly, theme underscore theme is equals to classic gray. Let's say dark, how dark looks like. So that's how we can play with graphs, and similarly we can create graphs on the map too. To create graphs on word map, we have many libraries. Uh, for example, tmap is one of them, which I will be using to show you some simple graphs. First of all, you need to install the package. Install package named tmap. After installing it, you just need to use it using the command library, and then name of the library, which is tmap. Run this, and this library will be loaded, and this library comes with the data of the word named word data. So you can load that data using command data and type the name of the variable, which is word. So it will download data of the word from this library. As you can see, now you can summarize the data and see what is in it. Summary of word. So it contains different variables: name, continent, area, population, EST, economy, and income group, etc. To create a graph of it, you just have to simply write tm underscore shape, and you have to provide a dataset of the word, which is in the word variable word, and it will create a word map. No layer elements after font. Okay, we have to provide layers with too, for which variable we need to create the graph. Let's say tm underscore polygons, and type the name of column for which we want to create data. Let's say income group. We want to create a graph and distinguish it by income group. Now it has created word map with respect to income group. You can see high income groups are uh, given this color. For example, America, Canada, Australia lies in this group. Then we have upper middle, etc. Currently the graph is not much interactive. We can make it interactive using a simple command, which is tmap underscore mode, and type it view. So tmap mode set to interactive viewing. Now if we run this command, we will be able to see some interactive view of it. Now you can see our graph is a lot more interactive than before. USA, Mexico, Canada, and so on. To change it back to the previous view, you just have to change the view to plot again. So it will be again set to the plotting mode. Similarly, you can change the data, you can modify the data and plot different graphs from it. For example, let's view the word data first before changing. View. For example, I want for a map of just Europe only. We want map of only Europe continent. So make sure we are using deployed library. We can check it from here. We are not using it currently, so we can use it. Deploy, and then we can collect specific data of Europe and create graph on it. Let's see, or create a variable Europe countries. Europe countries is equals to our data set, which is word, then pipe operator, then filter, and we want to filter on the basis of continent. Continent is equals to double equals to, sorry, Europe. Let's run this, and now you can see we have a new variable which only contains 39 observations, mean data of 39 countries. Let's plot graph on it. Let me change the view to interactive mode again. I like the interactive mode. And again tm underscore shape. Now our data source will be Europe countries, and polygon will be let's say the same polygon, which is income group. Now you can see our graph is only limited to the European countries. So that's how we can create graphs. And using tmap, we have different libraries for it. We can use it if we have data set of the world, we can create different graphs from it. That's that's it for now. Hope you understand it.